Hello students. So today we are going to perform our experiment for digital design. So the experiment name is to study logic gates and verify their truth table. Okay. We will do these things in multisim. So we are going to require these apparatus or equipments, the DC supply, breadboard, connecting patch cords, these LEDs, ICs we need. Okay. So basically these ICs are the gates only. Okay, the gates are inbuilt in the ICs. Okay, here I have written some theory of these gates: and, or, not, NAND, nor, XOR, XNOR. Okay, and here you can see the symbol of the IC with the input and output part. Okay, suppose we will take the AND IC. Okay, the IC number is 7408. Okay, and as we know that the output of AND gate, it remains high or 1 only when both the inputs are high. Okay, otherwise in other cases what happens, the output remains low. Okay, if we are giving both the input low, then the output is also low. If we are giving one input high and other input low, then in that cases also we will get the output to be low. Okay, here we represent the low voltage to be 0. Okay, as this one is digital part. Okay, and the high voltage to be 1. Okay, so in the experiment also, suppose if we are giving a IC, one input to be 5 volt and other input to be 0 volt. Okay, then that 5 volt would be termed as 1 and that 0 volt would be termed as 0. Okay, so basically we are going to perform the experiment in the multisim for verification of the output part. Okay, that whatever the theory says, that by giving the input in this way we get output in this way. Okay, whether that is happening in real part also or not. Okay, so that thing we will perform in our multisim, and basically these are the symbol of the gates only. But when we will talk about the IC looks like this thing. Okay, as you already know, there is a notch in the IC. Okay, and from the left side of the notch we start counting the pin numbers of the IC. Okay, suppose as I have there I have told about an AND gate. Okay, so here also I will take this AND gate IC. This one is 7408. This is quad AND gate. Okay, quad means 4. Okay, as you already know, bi means 2, tri means 3, quad means 4. Okay, so this one is quad AND gate. That means 4 AND gates are inbuilt in this 7408 IC. Okay, if we'll just zoom this thing. Okay, just look at this part. Here is this notch. Okay, so from the left side of the notch, the pin number of the IC is counted. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this one is basically 14 pin IC. Okay, and you can see here there are 4 AND gate, 1, 2, 3, and 4. Okay, so what basically this diagram means, that this AND gate, okay, it is present from pin number 1 to 3 in such a way that 1 and 2 are the input of this AND gate and the 3 is the output of this AND gate. Okay, and here for this AND gate 4 and 5 are input and 6 is the output. Similarly, 8 is the output for 9 and 10 pin, and the 11 is the output for 12 and 13 pin. Suppose if we are giving input to 1 and 2, then we will get the output to 3 from 3 pin only, from the third pin only. Okay, don't expect output to be come from this 8 pin. Okay, as you can see, this AND gate is from pin number 1 to 3 only. Okay, and here two pins are there also, one is ground and one is VCC. So this VCC is the power, okay, the DC power which we will give. This one is for initializing the IC. Okay, so that IC could work. Okay, and we are providing ground also. Okay, similarly other ICs are also there. Okay, quad or quad NOR, quad NAND, these kind of ICs are there. There are many different kind of IC also, in which you will provide, we can see only two type of gate. Okay, or only two number of gate also. Okay, so we will check the output. Okay, by giving the input, and we will just give the output whatever we have seen in the multisim in this observation table. Okay, so these one are the input one and this one is the output one. Okay, so basically we will perform these experiments only. Okay, so start with and only. Okay, so we will do the and part only. In the observation table we will fill the data. Okay, just I am just changing this value to 1 1. Okay, so now this one is okay. Okay, so just now we will move on to the one multisim. Okay, so this is one is the multisim. So for taking these gates we'll click on this TTL. Okay, so here you can see that there is 74LS, there is 74LS-IC. Okay, this 74STD-IC, then is 74STD. So basically, what is this LS? Okay, and what is this LSIC? So basically, when you will click on the LS part, we will get the symbol only. Okay, you can use the symbol and you can draw the block here, and you can perform the experiment easily. But when you will do the experiment in lab, you will need to perform that experiment on the IC. Okay, so basically this one is the IC, so we will perform the experiment on the IC only. Okay, if needed we can switch on to the symbol one also. Okay, so I will provide you the data for both the part. Okay, that how to do the experiment. Okay, so for 74LSIC. Okay, so when I'm going to click on any one of the IC, okay, it will show me that what this IC is. Suppose I'm going to click on this 74LS03D. So here you can see the function is quad 2 input NAND. Okay, so if you click on this one, this one, this one, okay, this part, this function will show you that what this IC is for. Okay, so now we need an IC for AND gate. So just check it that which one is AND one. Okay, so better I'm just going to put here this thing. This one is quad 2 input AND. Okay, so just click on the OK button, place the IC on this part. Okay, now I have put the IC here. Okay, now for giving it the VCC and the ground, we need the power source here. From the source, okay, from the source we will choose one ground here, take one another ground for giving the input to 0. Okay, and then we will can also choose the VCC for giving the high output. Okay, so this one is okay from our side. Now we can directly connect the wire from the VCC or ground to these pins. Okay, or we can use switch also. Okay, I am going to use here switch. I will tell you further that why we are going to use switch. Okay, firstly I will take the switch part here. Okay, so from the basic only. Okay, so we are going to use here a switch. So the best would be this SPDT. Okay, not as, why this SPDT we are using? Because it is having two parts. Okay, in one side and one part in one side. What does this mean? Actually I am going to tell you. Okay, two parts mean we can switch over the input to the output part. Okay, in two way directly. Okay, so that's why we are using here SPDT. We can use SPST also, but it will act as a simple switch only. Okay, why I'm using here this SPST switch, I will tell you these thing also. Okay, and for taking the output we will use here LED. Okay, we can use LED or we can use probe light also. Okay, indicator also. So just I'm going to use here probe indicator. Suppose I'm going to use here blue indicator. Okay, and if needed you could use here LED also. In the diode part we can choose LED. Suppose I'm going to take here red LED. Okay, so basically this LED or this probe one is for output only, for viewing the output only. Okay, so how we are going to perform this experiment? Okay, we have taken this one switch. Okay, when you will click on this switch, this will switch over from one part to other part. Okay, take one more of this switch, control C and control V here. Just move the ground little bit here, move these names from here to here. Okay, okay, now I'm going to just flip it horizontally, both these part. Okay, now it's okay. Okay, you can see here in the IC, if you'll zoom this thing, if you'll zoom this thing, you can see here that 1A and 1B are the input and 1Y is the output of this AND gate. Okay. Similarly, 2A and 2B are the input and 2Y is the output for this AND gate. Okay. Similarly, there is 3A and 3B and 4A and 4B. Okay. And 3Y and 4Y are the output for their respective AND gates. Okay. Here is VCC also. So we will just copy this VCC and we will provide one VCC here also. Okay. It is 5 volt. Okay. No issue. Connect one switch output from here and the other one to this 1B. Okay, now it's okay. Okay, just little bit zoom out from here and just connect from here to here. Okay, and this ground we will connect from here to here. Okay, again this thing also we will connect from here to our VCC. Similarly, we will connect this thing from here to here, ground. Okay, so now just see it when I will click on this S1, okay, switch, it will switch over to the ground, okay, and when I will click again on this thing, it will switch on to our VCC part. That means by clicking only we can switch over from the high to low. That means from 1 to 0. Here also the same thing, okay. Or if you want, you can just click on this key. Okay, the key is space. So when I will click on the space button, both of these will, S1 and S2 switch will switch over. Okay, so better is this thing that we will change here this key. Suppose take it to be A and this take it to be B. Okay, so when I'm going to click on the A button of my keyboard, this S1 switch will switch over, and when I will click on the B of my keyboard, this switch will switch over. Okay, so this is the reason I have used the switch here. Okay, so that by clicking on this A or B, or by clicking on this switch only, we can switch over to 1 and 0 of the inputs. Okay, so the reason why we have used the switch here, okay, is that by clicking on this S1 and S2, it is easy to switch over the inputs. Okay, we can switch over the input from high to low easily. Okay, by clicking on this S1 and S2, or by clicking on this A and B. Okay, suppose we haven't used the switch here, then what happened? Every time when we need to give here, suppose at this time I am giving here 1A, this 1A AND gate 1A input to be high, that is VCC. Okay, if we need to give it low input, then I have to delete the connection, this wire, and then I will connect this wire from here 1A to the ground. Okay, so every time we have to do that thing. Okay, and every time for that thing we have to run the simulation and we will get the output. But here what happens, we have performed this connection. Every time when we will switch over the connection here by clicking on this S1 and S2, or by clicking on this A and B of the keyboard, we will get the output directly here. We do not need to run the simulation and again. Okay, now I will connect the ground here for this IC. Okay, now the output for this 1A and 1B is 1Y. Okay, so I will just connect this thing here to the probe. Okay, so this one is 2.5 volt one. Okay, so you can use LED also here. Okay, if you want. Okay, so I will show you that what happens when we will use the LED also. Okay, so at this time you can see that both of this input 1A and 1B are connected to the high. Okay, this 5 volt. So run the simulation. So when you will run the simulation, just see here the bulb is glowing. Okay, this so this probe is glowing. That means the when both the input is high 1 and 1, the output is 1. Okay, suppose just switch over this thing. Now one input is 0 and the other one input is 1. In that case also the output is what? 0. What happens if we will just make this one input to be 0 and this one input to be high, at that case also we are getting 0 output, and when we are giving both the input to be 0, at that case also the output is 0. Okay, so that means that when both the input is 1, at that case only the output is 1. Okay, so this is verified by the help of this circuit diagram here. Okay, so if you want, as I have already said, you can use LED here. Okay, so for using the LED, I've just removed this probe wire here. This wire I will just remove, and I will connect here the LED only. Okay, so as already I know that this one is the P junction and this one would be the N, so I would connect this part with the ground. Okay, so I will just copy here a ground. Okay, since both the input are 1, so this LED should be glowing. So click on the simulation, just see here, since I have used a red LED here, so this red color is coming here. Okay, so if I will just switch over the input here, just see here the LED switches off. Okay, as one input is 0 and other input is 1, in that case this LED will not glow. If we will switch both the input to be 0, in that case also it will not glow. If we will switch on to be one input to be high and other input to be 0, that in that case also this LED will not glow. It will glow only when both of the input is high. Okay, as this one is AND gate. Okay, so I hope you have understood that how to verify the truth table by the help of multisim. Okay, when we have done this thing, as already I have said that I will tell you that how to use this thing instead of IC. We can use block here also. Okay, block means this thing which I have already told you. Block means the symbol only. We can use the symbol also, and we can provide use this thing to verify the truth table. Okay, so I have just verified AND gate. Okay, suppose I will just check here OR gate also. Okay, so for that thing I have to just choose here the OR gate. Okay, so I will choose get into the IC part. So the number would be 7432, I think. So it is 7432 74LS32. Okay, yeah, this one is OR. Okay, so when you click on this thing, you have to again do the whole of the connection here. Okay, so better thing is that just delete this IC, and just replace this IC, okay, with our OR IC. Okay, so just right click on this, click on the property, and click on the replace button. Okay, I have chosen here and now I am going to choose here the OR gate. So 7432 is our OR gate. Okay, so you can choose here 74LS32D also, or you can choose here N also. Basically these D and these are the packaging styles only of the IC. Okay, this doesn't affect the functioning of the IC here. Okay, suppose I am taking here the D, click on the OK. So now just check here, this one is our OR gate IC. Okay, so both of the inputs are 1 only. Okay, both of the input are high only. So when we click on this simulation, just check here, the LED is glowing. Just switch over this thing, one input is high and other input is low, again the LED is glowing here only. Now just change this switch at here, this input is low and this input is high, at that time also LED is glowing. Just switch over this switch, both the input are low and at that time the output is low. Okay, as we know that in the OR gate, when both the input are low, the output is low. Okay, so here by the help of this thing I have verified the truth table here. Okay, so remember, when every time you verify this thing, just write down that what you got the output. Okay, at input of 00, whatever you have got the output, at input of 01, whatever you have got the output. So basically this 0 and 1 is a presentation in the digital form. Okay, every time remember this thing is presentation in the digital form. Okay, the digital form is 1 and 0. Okay, this I am giving here 5 volt, that means that digitally we are assigning this thing as 1, and we are giving here ground or 0. Okay, if not needed, we can, instead of giving ground, we can give different voltage here. Okay, but that different voltage should be 0 volt. Okay, so that 0 volt would be termed as 0. Okay, and we are giving here high voltage, so high voltage will be termed as 1. Okay, so you can, instead of giving ground here, you can give the other VCC or VDD or VEE, but that to be 0 volt. Okay, so by the help of these things, we can verify other gate also, not, or, nor, and, NAND, XOR, and XNOR. Here it should be XNOR also. Okay, just make a column for XNOR also. Okay, so by the help of the ICs, you can perform the experiment. Okay, now as already I have said that I will make you go through these gates symbols also. Okay, so here I am getting taking here the AND. Okay, so for first thing, just delete this thing. Okay, I have replaced the AND IC with the OR IC. Okay, as both the IC's pin are same, that's why after replacing the IC of AND by the OR, this connection haven't changed. But here in the symbol part, since we are having only 2 to 3 pins here, okay, so in that case, this connection will get wrong. So better is that we will delete this thing firstly. Okay, and then just choose here 74LS08, click on the OK button. Okay, so just see here, when I click on this OK button, I am getting here ABCD. What is this ABCD? As we know that there were 4 ICs, okay, sorry, 4 AND gates in the same IC. So this A, B, C, and D are the notation for those AND gates. Okay, suppose click on this A. So this one is the first AND gate. Okay, we don't need another gates. Okay, by one gate AND gate only we can verify this thing. Okay, so connect on the first switch here and the other one to be here. Okay, and remember, we didn't need to connect the VCC or ground to this IC. Okay, as the VCC and ground are directly connected here. Okay, it is hidden. Okay, basically it is hidden. We don't need to connect it here, but we need to connect the output here. Suppose I am going to connect it in the this probe one. Okay, now since both the output is input is 0, when we'll run the simulation, this thing will not glow, as this one is our AND IC. Click on this one, both the input are high, that's why this probe is glowing. Now one input is high and other input is low, this one is not glowing. Here click on this thing, one input is low and other input is high, in that case also this one is not glowing. Okay, so by the help of this symbolic diagram also, okay, we can verify the gates and their outputs. Okay, so by the help of this thing, I hope you have understood that how you have to perform the experiment. You have to take the IC or the symbolic parts. Okay, and you have to check the output for all of these things. Not gate for A and B. Okay, for this one input, for this one, for A plus B or for A plus B not, that is not, and NAND XOR, and as already I have told, use here X NOR also. Okay, so this thing is the first part of the experiment. Okay, I hope you have understood that how to perform this experiment. Okay, and how to verify the truth tables. Okay, so thank you for watching the experiment.